Hi, I'm Paul from Easy Composites. If you want to get started making professional quality, high performance carbon fibre parts like these, then there's really only two ways to do it. One method is to use pre-preg carbon fibre, which needs to be cured at high temperature, which we have covered in previous videos, or you can use resin infusion. This video is all about the resin infusion method and will cover everything that you need to know to get started with this incredible process. We'll be taking an overview of how it works, we'll look at the materials and equipment needed, consider suitable mould types, then we'll get into the layup of the carbon fibre and infusion stack before covering how to set up your resin inlet and vacuum connections. And then we'll run the infusion, allow the part to cure, and finally demould it. Resin infusion is one of my absolute favourite processes in composites, and I've used it in projects ranging from flax fibre canoes and Kevlar expedition sledges through to various lightweight motorsport panels, a bit like the one we're going to be demonstrating with today. This manufacturing method needs very little setup and tooling cost, and so allows anyone with good practical skills to produce perfect quality parts with aerospace level mechanical performance. The information in this video is aimed at people who have never done infusion before, and so is only going to cover the essentials that you need to know to produce your first successful carbon fibre parts. So, what is resin infusion and how does it work? In simple terms, dry reinforcement like carbon fibre is positioned into a mould without resin. This is then placed into a vacuum bag along with some specialist layers that are going to help the process. All of the air is then drawn out of the bag using a vacuum pump, and then the resin is pulled through by that vacuum, and this saturates the fibre. This is then allowed to cure at room temperature, which produces the finished part. When done properly, resin infusion creates parts with the perfect resin to fibre ratio and extremely low void contents, meaning that the performance of a resin infused part will rival that of a pre-preg one and will be both mechanically and cosmetically better than traditional hand layup and vacuum bagging methods. Also, because the resin is not introduced until the very end of the process, you're not going to be working against time constraints caused by pot life, and the whole process is very clean and contained. To achieve a successful infusion, it's absolutely essential that you have the right materials and equipment for the job. The first thing we're going to consider is the reinforcement. In this demonstration, I'm going to be using carbon fibre, and for the surface ply, I'm going to be using a 210 gram 2-2 twill. This is our most popular fabric type, and that's probably because it is really suitable for most applications. Then, to reduce cost, I'm going to back this up with a much thicker 650 gram twill. Resin infusion will work with nearly all fibre types, such as carbon, Kevlar, glass and flax. In fact, any fabric that will easily allow resin to flow through it will, in theory, work. For positioning the fibre into the mould, a spray adhesive like the Fusion Fix EP will likely be needed unless the part you're producing is relatively flat, maybe a flat panel or a roof skin, then you wouldn't need it. Then we've got the resin itself. There are other options, but a dedicated epoxy infusion resin is where you should start. Infusion resins are designed to have low viscosity and the correct flow and performance under vacuum. A conventional laminating resin, for instance, will almost certainly flow too slowly for this process to work properly. So that's everything that goes into the part itself. All of the materials that we have from here go into the infusion stack. Again, there are a few options for the infusion stack, but what we're looking at today is really the most basic combination that's going to provide reliable results when starting out with this process. The first layer in the stack is the peel ply. This fabric allows resin to pass through it, but after the process is complete and the resin is cured, it can be torn away from the laminate, separating the part from the consumables. And it also leaves a consistent textured finish, which is great for bonding to. After the peel ply, we have the infusion mesh. This creates channels under the vacuum bag film that the resin can freely flow through before soaking down into the peel ply and then on into the laminate. This layer is absolutely essential, as without it, the resin would barely flow at all. Then we've got the infusion spiral. This creates a fast flowing channel where the resin enters the part. The resin can flow down this out from the spiral into the mesh and then on into the component. Then we've got the reusable silicone connectors. These are used for both the resin inlet and the vacuum connections. And the last layer in the stack is the vacuum bagging film. For most infusions, a 50 micron nylon bagging film like the VB160 is going to be an appropriate choice. And this is then sealed down to the mould using some ST150 sealant tape. Finally, on the consumables, we have the disposable PVC resin and feed vacuum hose. Okay, so that covers all of the consumables. Let's now take a look at the equipment. Resin infusion doesn't really need much in the way of equipment. Firstly, for successful infusions, you're going to need a vacuum pump capable of 5 millibar or lower. This equates to around 99.5% or better, which is quite a high level of vacuum. Typically, this is going to be an oil-sealed rotary vane vacuum pump like the EC4 that I've got here. The actual displacement capacity of the pump doesn't really matter, as it only affects how quickly the bag pulls down in the first place and doesn't affect the performance when infusing. In fact, I've used one of these small EC4s to infuse a 6-meter boat hole. Then we have the catch pot. This sits between the vacuum pump and the part, and it does exactly what its name suggests. It catches any resin drawn out of the part, protecting your vacuum pump from damage. It also features a gauge, which is really useful when you're checking the seal on a vacuum bag. To close both the resin inlet and vacuum lines, these line clamps are used, and these simply clamp down onto the tubes, pinching them to create a seal. Other things that you're going to need are release agent for your moulds, mixing buckets and sticks, some gloves and a set of scales. Now I do realise that this is a fair old list of materials. Fortunately though, we have made it very easy to get going with our resin infusion starter kit. This includes almost everything that we've just covered. You get the pump, catch pot and enough consumables to do over 5 square meters of mouldings. The only things that aren't included are the carbon fibre and spray adhesive and then the scales and release agent. But these are also available separately, and so I'll put a full list of everything I've used in this video on the project page, which you'll find linked below. To make a part, you're going to need a mould. Now, this might be a simple flat plate of glass or plastic if you're just making a flat panel, but most likely it will be a mould taken from an existing part or an original pattern. Moulds intended for resin infusion do require a little extra space around the perimeter to allow you to position your consumables and then seal your vacuum bag. I'd recommend having at least 100 millimeters here. It is possible to work with less, but you will be making your life much harder. Generally, infusions are cured at ambient temperature, and this really does open up a lot of possible mold making materials. Basically, anything that will be compatible with epoxy resin and allow it to release will work. Commonly, this is going to be fiberglass molds made with either an epoxy or a vinyl ester gel coat. Now, if you've not already made your mould and you're not sure of which materials to choose, then I would suggest the Unimold system to be one of the best options. That's what this mould's made with, and it's a very cost-effective and fast tooling method, which is perfectly compatible with epoxy resin. If you did want to know how to make a mould like this, then I'll put a link in the description to the Unimold user guide video that covers everything that you need to know. And it uses this exact mould as the example. One more point on moulds. If you are infusing with an epoxy resin, then traditional fiberglass moulds made with a polyester gel coat are very likely to cause problems with release, and so they shouldn't be used. If you are at all unsure on whether a mould will be compatible, then do a small test patch with the epoxy resin to make sure that it releases away without a problem. As with any composite process, a release agent will be needed to allow the cured part to freely separate from the mould. Now, all conventional release systems should work with infusion, but unless you have a specific reason not to, I would strongly recommend using a chemical release like the EasyLease CR1. These are really fast to apply, provide an excellent surface finish, and most importantly, will offer the best release performance. With the release agent down, the next thing I'm going to do is put the seal around the perimeter of the mould. Now, if you've watched any of our previous videos, you'll know that I like to do it at this stage, as I know that the flanges are completely clean and clear of any stray fibres or any spray tack residue, both of which could compromise the seal. In this example, I'm going to be using a layup that is very typical for lightweight panels. As you saw earlier, I'm going to be using a 210 gram twill on the surface, and this is going to provide that classic carbon fibre appearance that most people will be familiar with. While I could go on and just use 3 more layers of this to get the thickness of the part that I need, instead I'm going to be using 1 backing layer of a much heavier 650 gram fabric. Not only is this going to be quicker to lay up because I've just got 1 ply to put down, but it also works out to be much more cost effective. Now, as this is a beginner's guide, I'm not going to be covering things like alternative reinforcements and core materials. These are things to get into, but after you've mastered the basics. The carbon fibre is now cut to size. When doing this, oversize the cloth by around 100 millimeters, as this will allow more margin for error when positioning the material. Carbon fibre cuts really easily with any good quality shears or scissors. So we're now into the fun part, laying up the reinforcement. First, the surface ply is loosely positioned into the mould. Then, one side is carefully folded back and a light mist of Fusion Fix EP is applied. If your part is relatively flat, then this spray adhesive may not be needed, but generally it will be. Even though the Fusion Fix EP is epoxy based and completely clear, you're still only looking for a very slight mist coating on this first ply. If you use too much adhesive, it may show through onto the surface of your finished component. Give the adhesive around 30 seconds to flash off and develop tack, and then carefully unfold the fibre and press it onto the surface of the mould, working from the centre of the panel outwards. Keep an eye out for any stray fibres falling from the edge of the cloth. These do have a tendency of getting underneath your surface ply and spoiling the look of your part. You need to pay particular attention in sharp corners, as any areas that are not perfectly following the contours will bridge, leaving areas that will fill with resin. Not only are these weaker, as they are unreinforced, but they also create channels that will affect how the resin flows. If necessary, you can use a little more adhesive to keep them in place, but this should be kept to a bare minimum. The same process of positioning the fibre can then be repeated for the other side. Here I'm just putting in some relief cuts to mean that the fabric won't have to distort to get over this raised section. I'll later be trimming this out, so it really doesn't matter. With the surface ply in place, another light application of Fusion Fix is applied and the 650 gram cloth is positioned into place in just the same way. Try to do this as accurately and deliberately as possible to avoid repositioning, as this can lift and disturb the visual surface ply beneath. Both layers can now be cut back to size, leaving around 20 millimeters of overlap onto the flange. Everything that we do from this point forward is there to facilitate the infusion process and is known as the infusion stack. For this demonstration, we're going to be using the simplest possible configuration for this. The first layer in the stack is the peel ply, and this is that finely woven cloth that will allow resin to pass through it, but once cured can be torn away, and that will also remove any consumables that are stacked on top of it. It also provides a consistent textured finish on the back of the part, which not only looks great, but is also an excellent key for bonding to. The peel ply is positioned in exactly the same way as we did with the reinforcement. So we lay it into position. Using a light spray of adhesive, it's pressed all over the back of the reinforcement. It's no problem if you need to use multiple pieces of peel ply, but if you're doing this, you must ensure that they overlap and that all of the reinforcement is completely covered with it. The next layer in the stack is the infusion mesh or flow media. This is the layer that creates flow channels that allows the infusion to take place. If you look closely, it consists of 2 layers of ribs or ridges that are stacked on top of one another at an angle. And when this is sandwiched between the peel ply and the vacuum bag, these leave channels or corridors that the resin can easily flow along. From there, the resin can flow down through the peel ply and into the reinforcement. Without this mesh, the infusion would be so slow that it simply wouldn't work for most laminates. This can then be cut to size slightly smaller than the peel ply and positioned onto your mould, and then secured in place. Now, because this is made from polypropylene, a spray adhesive won't work to hold this down. It simply doesn't stick. But duct tape does, so use small pieces around the perimeter to secure it in place. Just like with the peel ply, you can use multiple pieces if you need to, but they must overlap. It's not really possible to get this mesh to follow all of the details and contours. It simply wants to spring out. But that's not really a problem, as it deforms and stretches very easily under the vacuum bag. If you do find that you need to secure the mesh further in larger spans, you can do this by spotting it down with a few tacks of hot melt glue down onto the peel ply. Now we're going to set up the vacuum connection and resin inlet and spiral. I know that this is an area that can be a bit confusing when you're new to Infusion, but it doesn't have to be. In the most simple setup, we would have a resin inlet at one end and a vacuum at the other. The resin would flow in through the inlet, down through those channels in the mesh and into the part. Now, in order to increase the effective size of the inlet, we can use a resin infusion spiral. This is simply a tube with a slit cut into it, and it's placed on top of the mesh and connects to the resin inlet. The resin then flows from the inlet rapidly down the tube and out through the spiral slit into the mesh below. Now, it flows around 10 times quicker down the spiral than it does along the mesh, so it does a great job of getting the resin to where you need it. Taking a simple 1 meter by ½ meter rectangular part as an example, let's look at some different layouts and how they would affect flow. I realise that you're probably not making a perfectly rectangular part, but all of the principles we're going to cover could be applied to almost any component. If we have our resin inlet and spiral at one end and our vacuum at the other, the resin will flow like this. You can see that it takes an arc shape from the connector and flows across the part, gradually getting slower and slower. In this case, we're asking it to flow 1 meter from one side to the other. If we were using a fast hardener, then our resin would have certainly cured in the pot before the infusion would complete. Not good. There is a rule to follow here when working with standard epoxy infusion resin and conventional reinforcement. Try to keep the flow distance from the spiral to less than 500 millimeters. So let's try this again. This time we'll reduce the flow distance by infusing across the part instead of along it, meaning that we're within that 500 millimeter rule. So we release the resin and now it easily reaches the other side within the pot life of the resin. But now we do have another problem. Our resin has hit the vacuum connector before the whole panel is infused, meaning that we can't maintain proper vacuum to these areas. This one is an easy one to fix. By positioning the inlet and vacuum connections at opposite corners, the flow will now reach the vacuum connection last. And so that gives us our second rule. Position the vacuum connection at the furthest possible point from both the spiral and the resin inlet. So in this layout, it would definitely be functional, but can we improve it? By continuing the spiral around both sides of the part, we can now reduce our flow path to just 250 millimeters, which will greatly reduce our infusion time. This time, putting our connections back into the center will mean that the infusion will hit the vacuum connection as its last point. You should always aim to keep the spiral and connections on the flange of the mould wherever possible and off the surface of the part itself. Otherwise you will get something called print through, which is a marking effect on the surface of your component. While placing multiple connections and spiral within a part is often necessary on large components, it is really beyond the scope of this beginner's guide. Now, the position of these elements is more forgiving than you might expect, and so if you follow the simple rules of a maximum flow distance of 500 millimeters from the spiral and position your vacuum at the point furthest from the resin inlet and spiral, you are unlikely to go far wrong. A question that we are also asked is whether flowing uphill, downhill or around corners affects the flow. Except on very large mouldings, no, this will not have a noticeable effect on the infusion, so it's certainly not something to worry about on your first projects. Now that we've got our infusion strategy worked out, the spiral can be positioned down onto the mesh using some duct tape. When doing this, it is really important to make sure that it is completely sat on top of the mesh. The resin inlet connector is then placed over the spiral at this side and then the vacuum connector at the other. It's best to cut away the mesh at the vacuum side of the part and place the connector directly onto the peel ply. This setup is known as a resin break. Without the mesh, the flow of the resin is massively slowed, meaning that the vacuum will be maintained over this area for much longer. You're going to see the effect of this when we run the infusion, and so its purpose should become a lot more clear then. The last part of the stack is the vacuum bagging film. For resin infusion to work successfully, it's absolutely essential to have a completely sealed vacuum bag, and so this is one of the most critical steps in the entire process. If you are going to be doing this, then please watch our video on vacuum bagging techniques, which is half an hour of useful information on vacuum bagging and is likely to save you from making some of the most common mistakes. I'll put a link to that below. With resin infusion, it's most likely that you'll be sealing your bag directly to the flange of the mould, and so you will need to add pleats onto the seal to ensure that you've got sufficient film to follow all of the contours without having to stretch. The frequency and size of these pleats will vary depending on the depth and complexity of your mould. The pleat is formed by attaching folded tags of sealant tape to the seal that we positioned earlier, and then the vacuum bag is carefully attached to this. Work slowly and methodically around the seal, pressing it firmly and checking for creases as you go. When you get to the very last pleat, it's really not uncommon to have to fold this over or extend it as needed. The disposable hose can then be fitted to the connectors. Cut a 45-degree angle onto them, then carefully puncture the bag over the fitting and press the tube into it. Any creases should be pulled taut, and a small piece of sealant tape is wrapped around the joint to seal it off. Using one of the line clamps, the resin feed tube should be firmly clamped and the vacuum line should be connected to the catch pot. When you do this, pass the hose at least 50 millimeters through the gland into the disposable liner cup and then firmly tighten that gland down. The catch pot then connects to the vacuum pump with a silicone hose and vacuum can be pulled. It's really important as you gradually pull the vacuum bag tighter to ensure that the bag and the consumables underneath are perfectly following the contours of the mould with no gaps or bridging. Any bridging that you do have of either the reinforcement or the vacuum bag and consumables will result in a resin-rich area on your part, or worse, a complete void. You'll normally need to periodically switch the pump on and off to give you time to do this. Once you're happy that it's into all of the contours, allow full vacuum to develop and then listen out for any hissing sounds that might be coming from a leak in the seal. If you do find any, then press and stretch the bag firmly to seal them off. Then do another visual inspection. Once you think that you've got it completely sealed off, then you will need to perform a drop test. There are a few ways to do this, but assuming you're using one of our starter kits, this is the procedure that I would recommend. Clamp the line between the catch pot and vacuum bag, then wait for 20 minutes. Then switch off the vacuum pump and unclamp the line. If you see the needle drop at all when you remove the clamp, then you have a leak and you will need to go around your seal again. If your bag fails the drop test, don't be tempted to run the infusion with a leak, however small it may be. This type of infusion relies on having a perfect seal, and running it with even a small leak will almost always end in a failed part. On those rare occasions when you can't find the cause of a leak, you'll have to remove the bag and redo it. Before we mix our resin, let's now take a quick recap over the setup to see what we've done so far. So we have our vacuum pump, which is connected to our catch pot. This in turn is connected by a bit of disposable PVC hose to our vacuum connection on the component. Then at the other side we have our resin inlet. So again, we've got some disposable PVC hose, our inlet connector, and this is where the resin is going to enter into the component. From here, it's going to flow into the spiral, and this effectively increases the size of the resin inlet over the part, and then it's going to go down into the infusion stack, which consists of a mesh, a peel ply, and then our carbon fibre reinforcement. Everything here is sealed under a completely airtight vacuum bag, which has been carefully pleated and work to follow all of the contours and details of the mould. We've performed our drop test, and so we're ready to go. To calculate the amount of resin needed per square metre of moulding, you should first take the total weight of your fabric. So in this case, I've got a layer of 210 gram and a layer of 650 gram, meaning I've got 860 grams of fabric in total. Then divide this number by 1.5, and that's going to give us the total amount of resin that will go into the part itself with a little bit of extra margin. Then we add a further 700 grams for the mesh and peel ply consumption, meaning that this laminate will need 1273 grams per square metre. This particular moulding is around half a square metre, so we halve the number, giving us 636 grams. I'm then going to add a further 100 grams to this to give me that little bit extra for the hoses and a bit left in the bottom of the bucket. If you're not sure about the amount of resin that you need, you can always mix up a little bit less than you estimate and then clamp off the resin feed line if it starts to run low. And then you just mix up some more, add that to the bucket, unclamp, and the infusion will continue. And you're not going to affect things by doing this. We've passed the drop test and calculated how much resin we'll need. Let's get some resin into this part. For the resin to flow and cure properly, you do need to have a good working temperature of between 18 and 25 degrees C. Being cooler than this will increase the viscosity of the resin and slow the infusion and the cure. Above this temperature, and the pot life of the resin is going to be significantly reduced, meaning you might not be able to infuse your part before it goes off in the pot. As we mentioned earlier, to ensure that you have the right flow characteristics, you do need to use a dedicated epoxy infusion resin. We'll be using the IN2. This needs to be accurately weighed and thoroughly mixed with its hardener. I would recommend using the slow hardener, as this will give you plenty of pot life while you're learning the ropes. Try to avoid whisking or whipping the resin, as you're going to introduce a lot of air by doing this. For infusions up to around 2 square metres, you will typically mix the resin in a single batch. The resin feed line should be taped to a stick, and then this in turn tapes into a bucket. This ensures that it doesn't fall out during the infusion. Now you can gradually unclamp the feed line until the resin reaches it. Wait for a few seconds for the air that was in the hose to be drawn through, and then fully unclamp and allow the resin to flow into the part. I've probably done this thousands of times, but I still find it satisfying to watch. You might notice some bubbles shooting forward at the flow front. These are not an indication of a leak, they're simply microscopic bubbles that were introduced during mixing that are now expanding massively when they're near full vacuum. It is possible to eliminate these by degassing the resin before infusing, but they don't really cause any problems in the part, so it's certainly not needed. As the infusion is reaching the resin break where we remove the mesh, you can now see how this works. Without the mesh, the resin flows so slowly that a drier area is maintained for a long time around the vacuum point. This allows time for any unevenness of the flow front to equalise before the vacuum connection is finally reached. The vacuum line should be firmly clamped once the infusion is complete and the resin can be seen in the hose. After this, the vacuum pump can now be switched off. As the vacuum bag is still under elastic tension at the moment over the mesh, the part will continue to draw in resin for a few minutes after the vacuum is clamped. I will typically allow 1 to 5 minutes of extra time for the resin to draw through, which, for some slightly complex reasons, tends to improve the surface finish of the part with almost no impact on its weight. Now that the inlet flow has significantly slowed, it can be firmly clamped and the part can now be left to cure at room temperature. The cure time will vary depending on the hardness speed you've used and the ambient temperature you're working at, but for this part, with the slow hardener at 23 degrees C, I'm going to be able to demould it in 24 hours. A good way to tell if the part is ready to be demoulded is if the resin in the feed line cracks sharply when flexed. If it doesn't, just wait a bit longer. The vacuum bag can now be torn away and then the peel ply and mesh removed. The easiest way to do this is to snip the peel ply at 100mm intervals and tear it back in strips. You will need safety glasses and gloves for this, as the cracked resin forms some pretty sharp splinters. The peel ply removal has already started to release the part, so with some gentle prying, it pops out with ease. I'm really pleased with the finish that we've got straight from the mould. You can see we've got that perfectly flat, glossy carbon fibre appearance. The quality of this appearance really comes down to the quality of the mould. The better the mould is, the better your part will come out of it. Even a fingerprint will transfer from one to the other. All of that hard work that we did put in earlier, ensuring that the carbon fibre and the bagging materials followed all of the details of the mould, has really paid off. As you can see that the carbon is perfectly following around all of these sharp angles with absolutely no bridging. Also, because we made sure that we got a perfectly sealed vacuum bag, we have absolutely no pinholes or voids anywhere on this component. And if this was going to be used for a lightweight application like in motorsport, it could just be trimmed up and put straight into use. But if it was going to be exposed to the elements, maybe in a daily driven car, then I might suggest keying this back and clear coating it with something like Phantom Clear to give it that extra bit of protection. But this one's for motorsport, so we can get this trimmed up using Permagrit wheel, then sand and deburr the edges, and we have our finished part. At 610 grams, our new carbon fibre component is less than quarter of the weight of the original component. So that's the beginner's guide to resin infusion. I hope that it's given some of you the confidence to try out this incredibly effective and useful process. It really does allow you to make aerospace quality parts with remarkably little startup investment. At Easy Composites, we can supply you with all the correct materials, consumables and equipment to guarantee that you hit the ground running. Of course, this being a beginner's guide, it has only covered the basics of a process that can get a lot deeper. If you're interested in that, then have a look through the learning area on the Easy Composites website for infusion guides on topics such as larger scale infusions, core materials, high temperature tooling, and natural fibres. Or click here for that video on how I made the mould for this part. From everyone here at Easy Composites, thanks for watching and see you next time.